Using a calculator to find length of sides. But before we do, I want to explain something that is very, very critical, because if you don't understand this, you can really mess up. And that is, on the calculator, you have a button called DRG. It might be abbreviated DEG, RAD, GRAD. However, it's on the calculator, not pointed out on this calculator. But this means degree, radian, and grad. And for the problems in the workbook, we'll always be using degree. Our circle has 360 degrees. Now the grad over here, the radian is not, it's more used for higher mathematics, but the grad here, it's used sometimes in Europe where circle has 400 degrees. And so if you press the number over here for a grad, you're going to get a wrong answer, because we work off a circle that has 360 degrees. So make sure your calculator is always on degree. Now let me show this on the calculator over here. And that's this button over here, DRG. Now notice this calculator. If I press the button, it goes to radian and it goes to grad. And it'll stay there. And this particular calculator, if I press on, it automatically goes to degree. Now we had a calculator at work, and we made mistakes with it. That if you put it on radian or grad, it would stay there even though you pressed it on and off. We got rid of those calculators because everything we do in our workplace has to do with degrees. So let's look at this example 1, tangent of 29. I'm just getting a habit. It's a good habit to get into, pressing clear all the time. You don't always have to, but it's a good habit to do that. 29 tangent equals 0.554309 rounded up to 1. So 5 places would be 0.55431. Let's look at cosine of 89 degrees. And it would be 89 and cosine, and that's the number we get for cosine, 0.017452. Let's do example 3 of sine of 18 degrees. Clear the calculator. 18 sine is let's just write that one down here. And that equals 0.30902, because we'll round that up. Now let's look what happens if we have radian on this. We'll clear the calculator. We'll clear everything up. Let's move that over to radian. We'll put, again, sine of 18 degrees in. Notice what happens. We're going to get a different number. Minus 0.75. You see it's a different number. And let's do the same thing for grad. All right, we can clear this and just put it over here. And sine of 18, and we're also going to get a different number here. That's 0.27899. So it's critical to make sure you're always on degree. Maybe later on in higher mathematics, you'll be using radian and grad, but right now, always use degree. Make sure your calculator is on degree. And now let's go and look at example 4. Find the length of the unknown side. That's x. And the first thing we're going to do now is label the sides. This is the known angle. This is adjacent, and this is opposite. Now in the book, it shows using the chart. You can go on the previous page and look at the chart, but I'm going to show you now using Sohcahtoa. And so what we have is an opposite and adjacent, and the other one that has both of them is Toa. So tangent equals opposite divided by adjacent. So tangent of 34 degrees equals x divided by 3.436. Cross multiply. So x equals tangent 34 degrees multiplied by 3.436. Let's go to the calculator. 34 tangent times 3.436 equals, and the answer is 2.3176. So x equals 2.3176. And so side opposite here equals 2.3176. Let's go to example 5. Again, let's label it. Here's the angle that is known, and this is the long side opposite the square over here, the 90 degrees, and so that is the hypotenuse, and this then is the opposite. Again, where do we have opposite and hypotenuse? Is SOH. So sine equals opposite 28,825 divided by hypotenuse. And this would be sine of 68. Let's put 68 in here. Let's just cross multiply. So 28.825 equals sine of 68 degrees times hypotenuse. We're going to isolate that, so we divide each side by sine 68 degrees, sine 68 degrees, and so hypotenuse equals 28.825 divided by sine 68 degrees. Let's clear the calculator. So 28.825 divided by 68 sine equals, and the answer is the hypotenuse equals 31.0888. And we use Sohcahtoa. You can also use a chart, but you can find that it's basically just simple algebra. Once you know the formulas, it's just cross-multiplying, isolating the unknown, and just plugging in the numbers into your calculator, and you'll get the right answers. This is Mike, and he operates this equipment over here, and he works for SBS. And what kind of machine is this, Mike?
This is a 4-axis CNC milling center. Computer-controlled numeric control is what CNC stands for. So it's computer controlled, but we still have to check locations and numbers according to blueprints that we have to make the parts to the customer specification. We do all kinds of calculations from radial angles. On the blueprint itself, it will tell you that there are holes that are going to be placed at so many degrees from another hole.
Okay.
And we have to calculate those angles and make sure that on our machine the part is going to rotate in the correct direction. You know, you can also make mistakes as far as making opposite rotation direction.
Instead of clockwise, going counterclockwise.
That's correct. So these are numbers that come out in the program as pluses and minuses, and we have to make sure that they're correct. And also we deal with drill point depths, because the way blueprints are usually called out, if they want a hole 500 diameter by 1 inch deep, they mean full diameter 1 inch, but that drill has an angle. Okay, so obviously the point of the drill is going to go deeper than the call out on the print. We have to know how much deeper. So here's where trigonometry comes into it. You have to calculate, this drill has a 135-degree tool point angle on it. So we will take half the tool diameter, which is 500 diameter drill. We're going to take 250 times 22.5 degrees tangent to give us that length from the break of the angle to the point of the tool.
So using trig also as the machinist?
Most definitely.
Let's look at this problem that Mike was talking about. He was speaking about a drill bit that was 500 thousandths in diameter and had a point of 135 degrees. And when they stipulate on the print, they want this drill to go in a certain depth. They might say they want it to go in, say, 750 thousandths. But when you bring that drill over here and touch this surface, and here's the point of the drill, how far does that drill go down from here? And so what you have to do, you have to use trig. And as a machinist working on that NC machine that he has there, he has to calculate now. And what he has to calculate is this dimension from here to here. And as you can see, this is what we got to find out. What is that dimension? And that's where you can use your trigonometry skills. Let's just redraw that. This is a right angle. All right. We know if that's 500 thousandths. You know that this is 0.250, 250, or a quarter of an inch. Now, if that's 135. We know that from here to here, it's 180. And minus 135, that's 5. And so that's 45. So both of these together equal 45 degrees. So we just got to divide that by 2. So 45 divided by 2 is 22 and a half. You can figure that out. So this angle over here now is 22.5 degrees. Now we want to find x. So let's label the sides. So we have the adjacent and the opposite. Have you noticed what he said? And that would be Sohcahtoa. That's the last one over here. Tangent 22.5 degrees equals opposite, which is x, over 0.250. Let's cross multiply. So x equals tangent 22.5 degrees times 0.250. Now let's go to the calculator and figure this out. So tangent of 22.5 degrees times 0.25 equals, and the answer is 0.1036. X equals 0.1036. So this depth here then is 0.1036. So now the machinist, if he picks up the point here, he can go in 750 plus 103, we say 4, round it up, be close enough for that, 458. 854 thousandths. Now the machinist could take that drill bit, touch the metal over here, and go down 854 thousandths, and then this will be 750 thousandths. Let's look at some other parts that have been drilled. And you'll find on this part there's many drilled holes. And trigonometry is used in making parts like this.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.